Hey guys, it's Mr. Grun coming to you from the book depository of the math department of Shakopee High School. Today we're talking about sections 3.2 and 3.3, which is sort of a combo of two sections, and it's on parallel lines being crossed by transversals. So the idea here today is going to be all about finding angle measurements, doing some algebra with it, and that sort of thing. So the first big topic here is this. When we've got this type of a diagram, really there's only two angles. There's 8 total, but there's only two, individual unique angle measurements. So in the warm-up section, what I'd like you to do is grab either a couple colored pencils or something, and you can fill this in whenever you have a chance, but I'd really like to make this diagram where we take one color and we fill in like this angle and then its vertical angle as one color, and then take those and do the same angles down in the bottom here. They're corresponding angles. All right, so now all of these obtuse angles are all the same color, purple in my case, and they're all equal to each other. And then let's take a different color and we'll fill in the rest of them. All right, so something like that, where now all these little acute angles are all the same color, all the obtuse angles are the same color. And we can really think about the pattern here, how the colors, if we pick these up and put them right back down on top of here, they all match. They're all the same. So now, let's look at it this way. Let's add this next to the diagram in your notes. All, we'll say, purple angles are equal. All red angles are equal. Now, change the color on yours if it's a different color, obviously, so it matches. And then we can say that a purple plus a red is 180 degrees. Because any combination here, purple-red, that makes a linear pair. That's 180 degrees. Well, if I do that purple and that red, it's still 180 degrees. But this purple and this red, still 180 degrees. Okay, so now some examples. Okay, so our first example looks something like this. We're finding the measure of angle ABC, and our diagram kind of comes across like this. We've got our two parallel lines being intersected by a transversal, and it says this is 80 degrees and this is X degrees. And it's asking us to figure out what this is, right? Well, if I think about this, if I break it up into like big angles, little angles, or I match it up with the colors, this one, that's less than 90 degrees. Well, this one also looks like an acute angle. Those are corresponding angles, so they're equal. So in this case, the measure of at X is equal to 80 degrees. And now the next one is pretty similar. Kind of comes across, our transversal comes across like that, and then our parallel lines cut across like this. And I think it's measure of QRS, right? And it says that this is 118 degrees. Now we're looking for this angle, is angle QRS on your diagram. And it's the same thing, right? We've got two angles, two big angles here. One that's 118. This one is also a big angle. This one would also, it's corresponding again. And so our measure for this one is also 118, or also the same, 118 degrees. 118 degrees. The next one tiny little extra step. Oh, actually, you know what? The next one, it turns out, is kind of the same thing. Only now they're alternate angles. So we've got a diagram that looks something like this. Parallel lines come this way and the transversal cuts across like this. We've got 125 degrees right here, and we're looking for this. Now again, if I think back to the stuff from Friday, these are alternate exterior angles which are equal. Or if I think about it in terms of like, this is a big angle, this is a big angle, or I compare it to that color chart, these would match up on the color chart. They're both big angles, they're alternate exteriors, so they're the same, 125 degrees on that one. And then our last one, our fourth example, it uses the same diagram mostly, except x gets moved over here. Now these are not like same side angles, they're not alternate exteriors, they're not verticals or anything like that. But if I think about the color chart that we made, or if I just think about like big angle, this is obviously an acute angle, so that's a little angle. Those have to add up to equal 180 degrees in this diagram. And so we're going to take 180 minus 125, and that should give us 55 degrees for that one. So really, like, you're either it's equal or you're subtracting from 180. Those are your two options. All right. Now a little bit of algebra. This is the one where we're finding the measure of angle DEF. And it's got a vertical line for the transversal, then our parallels kind of cut this way. And it says that this is 2x minus 45, and this is x plus 30. Well, here we're still going to start out the same way. We're going to think, are they equal or do they add up to 180? And in this case, well, this is an obtuse angle. This is also an obtuse angle. So they're two big angles. They have to equal one another. And so that's what we'll do with these. We'll set the equations equal to one another. Let's see, where do I have room to do this? 2x minus 45 equals x plus 30. And we'll solve that algebraically, then plug x back in. So x equals 75, now I can plug it back in. If they're equal to each other, it doesn't really matter which one I plug it into, so I'm going to plug it in down here because that one looks easier. It's just going to be 75 plus 30, which is 105 degrees. All right, now the next one gets just a hair more complicated. This is asking us to find the measure of TUS. My big head's probably in the way. This one looks like this. Almost horizontal for the transversal, almost vertical for the parallels. This is 13x, this is 23x. And it's again asking us to find the measure of TUS, which in this one I guess would be this one right here. So looking at this, deciding whether or not these are equal to one another or they add up to 180. This looks to be an acute angle. This looks to be an obtuse angle. An acute and an obtuse in one of these diagrams, they have to add up to 180. So we're going to take these two little equations and set them equal to 180 together. That means that our acute angle, 13x, plus our obtuse angle, 23x, have to equal 180 degrees. So it's really the same thing as before. The two angles add together to equal 180. Now our angles are just little equations. So anyway, combining like terms, 36x equals 180. Divide by 36, and I get x equals 5. Now, on your diagram, I think t is up here, u is up here, s is over here. So I'm looking at this angle right here as I trace it out. This is the one now I have to plug it into. So if we do 23 times 5, that's going to give us 115 degrees. And if I plugged it into here, it would give me, 65, and 65 plus 115 is 180, so that's a nice little check to make sure I did it right. Last two. Okay. Now, the question here asks, what value of x would prove that the lines are parallel? Really, it's saying solve for x. That's all it is. It's saying find x such that this thing is going to work out. So our diagram looks kind of like this, but now we've got 1, 2, 3, 4, 5, 6, 7, 8, and we're saying that angle 7 is equal to the equation 4x plus 25, and angle 5 is equal to the equation 5x plus 12. I still want to look at, I need to look at the diagram and decide which one is which. Whether these are equal or they add up to 180. Now, angle 7 is right here, looks to be an acute angle. Angle 5 is over here, another acute angle. They're corresponding angles, which are equal. And so I'm going to take these two equations and set them equal to one another. So 4x plus 25 equals 5x plus 12, and then solve that. So 13 equals x, and now we're done. We don't have to plug it back in because it's just asking us to solve for x. So boom, 13 equals x, x equals 13. I could plug it back in and make sure that it works just to be, as a check for myself, maybe on the test. I've got a note key that I'm looking at that I know is correct. So I don't really have to. Okay, and then the very last one, similar diagram, but the order in numbers is a little bit different. 5, 6, 7, 8, like that. And now we're saying angle 6 equals 6x plus 18. Angle 7 is 9x plus 12. Again, I'm looking at my diagram and making the decision, are these equal to one another or do they add to 180? Angle 6 appears to be acute, and angle 7 appears to be obtuse. Those are two different colors in the color chart. It's an acute and an obtuse, a little and a big, and they're also same side interiors, which I know add up to 180. So now we're going to do the same thing that we did before in a previous example for angle TUS, except now with slightly bigger equations. So I want to start this out by doing 6x plus 18, my first equation, plus the second equation, 9x plus 12 equals 180. I can combine like terms, so if I color code it, I've got two quantities of x, and I've got two numbers. Those are the things that I want to combine. 6 plus 9 is 15. 18 plus 12 is 30, equals 180. Then it's not too tough after that. And there you go. No, not 15. there you go. See? Good thing to check. I had my answer key to look at. If you would have plugged 15 back in, we would have come up with numbers that added up to way more than 180. Try the homework out. Please circle at least one problem that you're having trouble with, and when I get back on Tuesday, we will cover that in class.